Hey, my honors kids. So we're doing this by video. So if you're in my class Thursday, you're going to watch a video Thursday. If you're in my class Friday, you're going to watch it Friday. Now here's the homework. It's 2 different assignments due on Monday. So we actually have a 3 homework check on Monday. We have the graphs that I gave you. And we have this, and then you have this. Now, to be honest, you should be able to get this done in class. Maybe most or part of this. But a 3 homework check. Now, I plan to post this today or tomorrow or someday. But anyways, let's start off. Whoops. These are called matrices. Now, I didn't know this till my mom passed away, but she actually kept a matrix of Christmas cards. So she would have the name. She would have, did she get a card last year? She would have address. And she had some other titles. So she had name of the person, address. Did she get a card? Now, I didn't know this, but if someone didn't send her card in 3 years, she dropped them off the list. So she actually had my nephew, her grandchild, put this on the computer. So every year she would push a button and then the envelopes would come flying out. Really neat. Now, something else that's funny, the way she kept this, if she got a card, she did happy face. But if she didn't get a card, it was sad face. Well, I always went to visit her, so when she passed away, we looked up. I had 3 unhappy faces in a row because I didn't send a card because I traveled 600 miles to see her every Christmas. But anyways, so these are matrices. It's kind of the way you can think of stuff being stored, but it's a way to store information. I don't want to get any more detailed than that. Now, the first thing you do is you give the dimensions, how big it is. These are called rows going across. These are called columns. So this would have 2 rows, and then it would have 2 columns. So it's a 2 by 2. This one also is a 2 by 2 because it's 2 columns, 2 rows. Said that wrong. 2 rows, 2 columns. Now this one, what would this be? Well, it's 2 rows, 1 column. So it's a 2 by 1. This one is also a 2 by 2 because we're going to use them. But let's look on this side. How big is this? What's the dimensions? Well, 2 rows, 2 columns, so 2 by 2. This one, also 2 by 2. What is this one? Well, 2 by 1. And what's this one? Let's see, 2 rows, 3 columns, so it'd be a 2 by 3. Now that's going to be important. So let's start off. How do you add matrices? Well, first, you can only add if they have the exact same dimensions. So I can add A to B. So if you want to 2, 3, 1, 4, and O2, 1, O. So now you just add the ones in the exact same space. Now this would be 1, 1. Row 1, column 1. This would be row 1, column 2. So you add the ones in the exact same location. 2 plus 0 is 2. 3 plus 2, 5. 1 plus 1, 2. 4 plus 0, 4. So B plus C, are they exactly the same? So you'd say cannot do. Do not have the same dimensions. Because this is 2 by 2, but this is 2 by 1. It's got to be exactly the same. So how about A plus D? Well, A is 2 by 2. D is 2 by 2. Hey, they're the same, so I can combine them. So 2, 3, 1, 4, and for some reason my light just switched. Plus 3, 1, 4, negative 1. So spot 1, 1, spot 1, 1, so that would be 5. Spot 2, 1, second row, first column, plus that location, that'd be 5. 3 and 1, row 1, column 2, that's 4, and then 4 and negative 1 is 3. So adding should be pretty easy if they have the same dimensions. So can I add A to B? Yes. Can I add B to A? Yes. They're both same dimensions. Can I add B to D? Yes, same dimensions. How about C to D? No, not the same dimensions. Now, this is called multiplying by a scalar. Oh, that may be a C. Scalar. Now, what you do when you have a scalar out front is you just multiply every term inside by that number. So, negative 2 times the matrix A, we would have negative 2 times 2, that's negative 4. Negative 2 times 1, negative 2. Negative 2 times 3, that's negative 6. And negative 2 times 4 is negative 8. So 3C, what would that be? Go ahead and figure it out right now. Okay, C is 1, 2. So that would be 3, 6. 3 times 1 is 3. 3 times 2 is 6. So if I said, what's 3B minus 2D? Well, first, I'd multiply B by the scalar 3. So that would be 0, 3, 6, 0. Plus, now I'm going to multiply this by the scalar negative 2. So that would be 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. 1 times 1 is negative 2, and then that's 2. So I multiplied B by 3, doop, 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 and then I multiplied D by negative 2, doop, 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 doop. So now I just combine them. 0 plus negative 6 is negative 6. 3 plus negative 8 is negative 5. 6 plus negative 2 is 4. And 0 plus 2 is 2. Now here's where it gets tricky. Tricky, 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 tricky. Here's our matrix. You know what? I'm going to make a second video on multiplication because I don't think I have enough time and I don't want to rush it. So you have 2 videos to watch for this class. Let me do that.